Let's take a look at the future. Let's take a look at IPv6 addressing concepts. IPv6, I got to start by telling you this. It is much, much more than just the address space. But that's all you tend to hear about. We hear about the address space, but it's more than just about the address space. Lots of great benefits, lots of great efficiencies, lots of great new features will be made possible for us based upon this exciting new protocol. But sure, it's mainly the address space expansion that we hear about because of the incredible issue that the IPv6 address space exhaustion causes us. So sure, the expanded address space gets all the great press, but I do want to impress upon you that we will be interested in migrating to IPv6 for more than just the expansion of the address space. We know that IPv4 uses a 32-bit address space. This can accommodate approximately 4 billion addresses total. Well, just to blow your mind, just to really, really shock you on the size of the IPv6 address space, understand that it uses 128 bits, and thanks to exponential math, this means it's an address space that is so big, you could have the 4 billion v4 addresses for every single person on the planet. That's right. It's so big that every single person on the planet could have the size of the v4 address space. What would you do with 4 billion addresses? Wow, you could give an address to your dog, your cat, your goldfish, your refrigerator, your car, your toaster oven. And by the way, as the TCP/IP functionality in that intelligence is built into more and more devices, that's not all that far-fetched of an illustration, is it? Yeah. More and more devices will receive not just one, but multiple TCP/IP addresses in the future. And this is because of the fact that this intelligence is being built into more and more devices. We know that in IPv4, the format that is used for the addressing is what we call that dotted decimal format, right? We know that there are 4 octets. We like to go ahead and represent them in a decimal form, a dotted decimal form most particularly, and this is a great convenient way for us humans to deal with these particular addresses. Well, that would be a bit cumbersome in the v4 world, so instead they go back and use a hexadecimal representation approach. So we're going to do hexadecimal. Notice that 2 hexadecimal characters equals 1 of our bytes, and we are going to go ahead and divide the address up into these 16-bit segments. So we've got 16 bits, then a colon, 16 bits, then a colon, 16 bits, then a colon, in order to represent the address. Something that's very, very important for you to know is the fact that we do have some shorthand notation that we can do to make these addresses as brief as possible. I mean, you certainly want to make these addresses as brief as possible. Let's see if I put together a slide for you on that. I actually didn't. So let me go ahead and cover that with you. That is important for you to know. So here is the overall format of the address, right? Now, there are 2 rules for making these addresses more succinct when you have to write them out. Maybe at the command line, or maybe you're providing some documentation on your IPv6 implementation and you need to represent these addresses. The 2 rules are as follows. In any of the fields, you can go ahead and you can drop leading zeros. Okay, so you can go ahead and just not represent the leading zeros that might exist in a particular IPv6 address field. You can do this for every single one of the fields. All right, so any leading zeros can be dropped. And then number two, once in the address, one time in the address, you can go ahead and represent any successive fields of zero. So let's say you had 0, 0, 0, 0 somewhere in your address. All right, a big long succession of zero values. Once and only once in the address, you can go ahead and you can represent that as a colon. So you can represent this big succession of zeros as simply colon. Pretty cool. That is just once, though, that you can do that in an address. So you can come up with some really succinct looking addresses. You know, maybe in the first character fields, you have 2001, and then you've got your colon, and then you've got maybe 54 because you dropped the leading zeros. Then you've got your colon, and then you could do, like, let's say you've got 22, you drop the leading zeros again, and then you can go colon, and then you can have your maybe your last representation of 1. So notice that's the entire address right there. We've got 2001 54 22 1. That's the entire address. So the addresses can be shortened nicely, and that's important when you have a 128-bit address. You want to be able to represent these addresses as succinctly as possible. Now, notice that there are different addressing architectures in use here. Same kind of concept as we saw in v4. Things like they took the first 3 bits and they went ahead and they forced them to 001 for the global unicast address space. So when an address begins 001 in IPv6, it's part of your public internet addressing. If an address begins 1111, 1110, 10, this is a link local unicast address. Link local addresses are very important in IPv6. This is a really nifty way for IPv6 devices to be able to communicate with each other, even if there has been no assignment of any addressing whatsoever. Wow. So an IPv6 device comes up, it automatically gets this link local address. Another device on the segment comes up, it automatically gets its link local address, and the two machines can communicate. Pretty cool. It reminds me a lot of the automatic private IP addressing feature that Microsoft workstations will use. As you probably know, if Microsoft workstations come up, they can get no IP address space. They automatically configure themselves with a, I believe it's 192.168 type address. Actually, they reserved an address for it, didn't they? It's not 192.168. Let me look it up real quick. I'm curious. Microsoft went ahead and came up with an address space that's private use only in addition to the RFC 1918 in order for this automatic private IP address feature. Let's see. IP automatic Let me just type. I'm doing a search here on another machine, by the way. I know you can't see what I'm doing, but don't worry about that. Microsoft Automatic, let's see, IP. Okay. The feature is called Automatic Private IP Addressing, and they use the 169254 space. 169254 is the space that is reserved for that. So, interesting. This reminds me a lot of that feature. It's going to enable the devices to generate addresses automatically. They're only valid for the local link, and they can allow those devices to communicate. Very, very important feature. By the way, they had set aside site local use addresses, kind of like your RFC 1918, and then they said, you know what? That's a terrible idea. So they went ahead and they deprecated that idea. So there is nothing that's directly associated with the site local addressing. They did away with that idea. There's something fairly similar called unique local addressing now, but it's not really like RFC 1918, because here's the deal. They're almost guaranteed to be unique, these addresses. You know, when we do RFC 1918, we know that we have duplication all the time with another corporation, don't we? If I give my machine the address 10.10.10.1, for instance, my goodness, there's got to be hundreds of thousands of machines out there that are also numbered 10.10.10.1. With unique local addressing in the IPv6 infrastructure, it's almost guaranteed that it's the opposite. It's almost guaranteed you're unique. Of course, there's got to be multicasting in IPv6. We know how much we love the concept of multicast. And not only is there multicasting in IPv6, but it actually replaces broadcasting. That's right. There is no such thing as broadcasting in IPv6. So no more broadcasting in the IPv6 protocol. It's completely replaced by the concept of multicast. So, very, very important. Our global unicast addresses, by the way, they're going to look like the number 2000 to 3FFF. Your unique local addressing, which replaces the site local concept, those will stick out like a sore thumb because they start FC00. Your link local address for use only on the local link, those stick out like a sore thumb, FE80. And finally, multicast addresses begin with the designation of Foxtrot, Foxtrot. One of the great features that we have available to us with IPv6 right out of the box is the ability of the machine to give itself its own host address. This is really, really impressive. You see, in IPv6, we can have what is called stateless auto configuration. Yeah, you see, we know that there is the concept of automatic configuration of IP addresses, right? And when we do it in the most common form, it's called stateful. It's called stateful, and this uses DHCP. Why is it called stateful? Well, because the DHCP has a database that it is going to maintain for the addresses that it gives out. It's a stateful concept, isn't it? It's statefully tracking the addresses that it gives out, who has them, how long they've had them. In IPv6, sure, we can still have DHCP, by the way. If you're in love with DHCP, you'll be happy to know there is DHCP for v6, sure. But what's really cool is you don't have to use that. you can do what's called stateless auto configuration. And with stateless auto configuration, what happens is you can have a router come up, and the router makes a connection out to the workstation. The workstation says, hey, what is my network? How are they communicating? Well, they're communicating utilizing the IPv6 link local address. Remember, they're able to communicate thanks to those link local addresses. The router says, oh yeah, no problem. Here is your network prefix. And then the host automatically configures its host portion. Pretty cool. It's able to automatically configure its host portion thanks to a technology known as modified EUI64 addressing. What the device does is it says, well, gosh, I'm smart enough to configure my own host address. I don't need an administrator for that. I've already got a 48-bit unique MAC address. It takes its 48-bit unique MAC address and it does some manipulation. It inserts some bits inside and flips around some bit settings and fun stuff like that. It inserts some stuff in the middle of the address, and it automatically configures itself with its 64-bit host address. And this is important for us to realize. The IPv6 address is going to be 64 bits for the network portion, and it's going to be 64 bits for the host portion. So this 64 bits for the host addressing that an IPv6 station will use, hey, not a big concern for us because the station can automatically generate 64-bit host address. Very, very cool. IPv6, when it comes to address resolution, there is a much, much cooler technology, much more sophisticated, that replaces ARP. It's called the ICMP v6 neighbor discovery concept. Also, what's cool is the fact that we notice that this is an extension of the Internet Control Messaging Protocol. By the way, ARP, we know, it was based on a broadcast technology, so that led to some inefficiencies with ARP. This neighbor discovery process that replaces ARP, it's based on the Internet Control Messaging Protocol. So that's a bit more sophisticated. So I don't have an official slide for it, but let's go ahead and review this information with a couple of questions that I will pose to you. Okay? Let's go through some review questions, just kind of informally here on our whiteboard. The first question, how big is an IPv6 address? And we know the answer, 128 bits in length. Great. How big is the host portion? 64 bits in length. Awesome. What is an address that begins with F? F? Yeah, we know this is an IPv6 multicast address. Very good. How do devices discover the layer 2 address of a system? How do they replace ARP? Great question. ARP functionality is replaced in IPv6 thanks to the ICMP for version 6 neighbor discovery technology. So ICMP v6 neighbor discovery replaces ARP functionality in IPv6. Well, we've got more exciting information coming to you on IPv6 in our next lesson here in our 5-day CCNP bootcamp.